Alright, so in our last video, I was showing you guys how the voltage on the CC lines, which are coming from here and going back and forth between the decoy, which is requesting power at different levels, and then the adapter. So CC lines weren't, the voltages on them weren't big enough to be able to read them. So I created a little board like this that's basically an amplifier that makes a signal go from like 1 to 5 volts so you can read it, and we're going to show that and then we'll show how you can actually read the data now with the logic analyzer, see the data. We got to connect up the oscilloscope. So how does the decoy determine, how do you get the decoy to determine which level volts to pull up? Is it just that dip? Yep. Dip switch there? Yeah, so you change the dip settings on this little decoy, and then you can request 5 volts, 12, 15, and 20. And that's usually how I make it change the voltage, is I just click one of the switches. So right now what I've done is I've connected the oscilloscope up, because I can show you what our last video, on video part 1, and this is part 2 now. Part 1 we showed how the voltages weren't enough to be able to read it. So now if I hit, I've got it set so it's triggering the oscilloscope, and it'll trigger as soon as the voltage gets somewhere between, well, I'll put it at 3 volts. So now if I click this thing, you see all the data coming through. Now, if you look, it goes up to about 4 something and then down to about a couple hundred millivolts. And that you can read with the logic analyzer. Right. So now, I'm going to take the oscilloscope off and we're going to hook up the logic analyzer. So I'm going to hook up, I only use one CC line. There you go. So the CC lines actually stands for configuration channel, and that's what it's all. There's 2 CC lines because they're like mirrored or whatever. We only use one at a time. But so I've got it all hooked up. Now we're gonna pull up the logic analyzer tool, and run, and then I'm gonna quick flip the switch. So now we'll zoom in on the data, and actually we'll delete this USB PD, and I'll show you how to add that. So if you close out on the pulse view, all you got to do is go up to this little green thing that says add protocol decoder, and they make it really easy. Just go USB and you can do PD. Double click on it. There's no channels assigned, okay? They're giving that little red signal. Well, if you go up here, you can say I want channel 0 to be, or D0 to be that's the one that we're using. And then it automatically decodes the data. So we'll move this up to here so you can see it. So now you can see the data. Now, if you look at the voltage that's being used, it's 5 volts, which isn't a great example because that's the default. So actually, maybe we'll run it again and I'll flip the switches so that we get something that's, more interesting. So now, let's look. So we've got 12 volts on you can see 12 volts on the little reader. The little reader. And so now if you go on here and you can see you've got all these right here, 1, 2, 3, 4, and 5 are what's being offered for the adapter, okay? So the way it works is this section, the first section is when the adapter is saying, here's what I've got. The second section is called, and if you look at here, it says USB PD types. You got source, GoodCRC, source capacity, GoodCRC request, GoodCRC accept, GoodCRC. So GoodCRC stands for cyclic redundancy, and cyclic redundancy is basically checking to make sure that it's sending a bunch of stuff to make sure that it didn't miss any data or get it wrong. Preamble basically is a bunch of 1s and 0s being passed just to get everything synced up. SOP is called start of packet, and that's just meaning, hey, by the way, we're about to send you packet. Then you have a header, which is your data, and then you have a CRC. It sends all the data here, 1, 2, 3, 4, and 5. And you can see it offers 5 volts at 3 amps, 9 volts at 2.2, and then 12 volts at 1.67. So it's dropping the current as you go higher in voltage because the power level is staying about the same. And you can see it says 19 watts, 20 watts, 15. So the most you ever get is about 20 watts, which is why it's dropping the amps. And then here, you got programmable PPS mode. And basically you can go from 3.3 to 5.9 at 3 amps, or you can do 3.3 all the way up to 11 volts, but only at 1.8 amps. So they change the current because you can go higher. So there's all the offerings. Now you can see what was actually requested by our little adapter.
So you could get like 2.8 volts or 2.89 volts if you wanted to.
Yep.
You could request literally any voltage you want.
Yes, it is an increment of about, I think, 20 millivolts. So obviously if you want something between the two increments, you aren't going to get that. And then if the adapter is not very good, you also might not get exactly what you think either.
Yep.
But then the request, it says PDO 3, and it says 12 volts at 1.67. So that's requested, and then it says good. This actually GoodCRC is sent by the adapter. So the adapter sends it back to this. So it made a request, then the decoy, the chip that's requesting, gets this CRC from the adapter, and then it sends the accept, and then there's one more GoodCRC. So it's back and forth. Hey, did you get what I wanted? Yep. Okay, we got it. Okay, and then it sends more. So what I'm going to show you is, this is the document. It's 1,047 pages just to define all the specifications on what needs to happen with USB power delivery. But there's actually a lot of good information in here, like CC lines. I wouldn't know what it means, but right here it says C configuration channel. So there's a lot of information in here that I'd like to go through in a future video. It talks about basically the power data objects. What is that? PDO. Okay, well, if you go back to here, these are your PDOs right here, and then it asks for a number. Basically, you're indexing 1, 2, 3, 4, 5. Which one do you want? Oh, I want number 4. I want number. It's like a menu. It's like literally a McDonald's menu. So this is, I mean, it's pretty cool stuff. But I want to dig in more, like in depth on like how to look at read these little symbols, and like actually, like if you didn't have the PD thing, could you make it from scratch yourself? Like, so let's dig into that. But basically, this is part 2. So now we'll have a part 3.
I think it'd be cool to make this into like a little power supply to like get any level you want. Just, you know, plug it in. Say you want 4.5 volts to test a little circuit. Have a little decoy that instead of has this dip switches to have something you can tell it, maybe a rotary encoder or something, and get exactly what you want out.
Yeah, you could do that. I mean, the thing is, you only ever be able to get 5 amps, and because it's USB-C, so that's only the spec. And then also you have to make sure you buy a power supply, you know, the upstream from this that supports PPS mode. Because I just happen to have a very inexpensive power supply that supports PPS mode, but it could offer 5, 9 volts, 12 volts, 15, and 20, and all those 5 would make everything, and you would not be able to have anything in between. So it really depends on what the PDOs are. And so anyway, so this was part 2. Stay tuned for part 3. We got this little board here now, and this will really help us be able to do some more troubleshooting and digging in. This is kind of an overview on how the CC lines actually configure your voltages. Stay tuned.